everybody. Welcome to another MCAT ACE lecture. And in today's lecture, we're going to be covering the general chemistry topic of mass, moles, and molecules. So to give you an overview of what we hope to accomplish in this lecture here, the atomic structure of an atom is first going to be brought up. Just a basic review as far as protons, neutrons, and electrons and how they are assembled. And in particular for this lecture, because we're going to be talking about mass, we need to discuss how we determine the mass of a given atom when we're looking at protons and neutrons. So from there, we'll start discussing the atomic mass unit, which is abbreviated AMU. It's a very common unit that is utilized when people first start learning chemistry, and then we tend to use molar mass as we move along and start talking about grams per mole. The AMU is sort of upgraded and upscaled because most of the time we're dealing with things on a macroscopic level. We're talking about measuring out milligrams or grams, not individual atoms or molecules, which is more relevant to the AMU, the atomic mass unit. So we want to discuss the atomic masses that we find on the periodic table, because when you take a look at an atom and add up the protons and neutrons, you would expect a very straightforward mass, assuming a proton and a neutron is each one AMU. And then sometimes when you get to the periodic table, you don't see these whole nice numbers. You'll see something like 63.5 for copper. And so that sort of implies that you have half a unit, either half a proton or half a neutron that's there. Most of the time it comes out that it looks like it's half a neutron. And when that occurs, you need to understand where that's coming from. That's really coming from the fact that there are multiple isotopes of copper or carbon or nitrogen or any of these compounds. There's usually multiple isotopes, and the weight or the mass that comes on the periodic table is a result of these isotopes and their average based on their natural abundance. So we'll talk about that for a few minutes and take a look at isotopes and use an example there. So then we're going to head into talking about the mole. And the mole is the central unit of chemistry. We always deal in moles when we're working with chemistry. And then from moles we can convert to atoms or molecules, we can convert to grams, but moles is the central unit. So we want to define what is a mole. You can be certain that Avogadro's number is going to come up when we start talking about this section. And then finally, we're going to talk about determining molar mass. So what happens once I go past a single atom, right? How do I find the mass of water or glucose or things like that? And then finally, determining the moles or the atoms in a molecule. So this would be sort of taking everything together, where if I have, let's say, 20 grams of water, and I want to know how many individual water molecules I would find in 20 grams of water, that's the type of calculation we're talking about doing there. So I will mention, while this particular lecture and subject is not stoichiometry, this is the prelude to stoichiometry. We're going to be starting to talk about stoichiometry very soon after this lecture, because then you're getting into balancing equations, which can lead to limiting reactants and percent yields. And then we can start talking about concentration and molarity. We can start talking about titrations, which require balanced equations. So all of this is sort of your pregame, or your preparing, your training for stoichiometry. That's what this lesson is really going to be about. But I don't want to classify it exactly as stoichiometry, because stoichiometry really has to do with the ratios when we start looking at balancing equations and how many moles of one compound give us how many moles of another compound in those balanced equations. So different subject for a different lecture, but keep in the back of your mind that this is where we're headed with this subject. We're going to start talking about stoichiometry eventually.